Does the following function have a maximum or a minimum? Find the value. All right, to solve this is actually pretty simple. They're basically saying, hey, is the function opening up or opening down? Because if you think about it, it's a quadratic function, right? And a quadratic function with a leading coefficient that's positive means that the function will open up. So it's going to look something like this, right? And if it looks like this, then this value, the vertex, represents a minimum, right? So we'd say the answer to the first question is that this function has a minimum. All right, so once you know that it has a minimum, then we just have to sort of find that value, and that means find the vertex, and that's not too bad. Now, we've been doing completing the square to kind of write it into this format over here, the a times x minus h squared plus k, but since we've done that a bunch of times, what I'd like to do now is to use a shortcut, which I have labeled there in green, which says the x-coordinate of the vertex is negative b over 2a. Now, when they refer to the minimum value, what they're really looking for is the y-coordinate, right? The f of x value of the function. So we'll have the x-coordinate by using that simple formula, but we have to do a step more beyond that to get the actual y value. So remember, when they refer to the minimum or maximum, they're really referring to the minimum y value, right? Okay, so let's go ahead and use the shortcut formula to find the x-coordinate of the vertex, because if we know where the x-coordinate is, we can certainly get the y-coordinate. Well, the shortcut formula is just what? That h for the vertex will be equal to negative b over 2 times a. Well, the b term here is 4, so negative b would be positive 4, and 2 times a would be 2 times 3, so you'll end up having 4/6, or in other words, 2/3, right? 2/3. Okay, so 2/3 is the x-coordinate of the vertex. Remember, that's not what we need though, because we need the y value. So in order to get the y value, all you have to do is to take that answer 2/3 for the x value and plug it into the function. So basically we're looking for f of 2/3, right? So we will have 3 times 2/3 squared minus 4 times 2/3 plus 2. And from there, it's just a matter of cleaning things up a little bit. So we'll have 3 times 4/9, right? Minus 8 over 3 plus 2. And if you work out all that arithmetic, you'll actually get 4/3 minus 8/3 plus, if I wanted to write 2 as a third, I can say what? 6/3, right? Because 3 goes into 6 2 times. And now everything's over a denominator of 3. We can then just combine like terms. So we'll basically have 10/3 minus 8/3 or 2/3. So 2/3 is the minimum y value. This is the y value that we're looking for, right? And this is the smallest y value that we have on the graph. And if you graph the function, you'll see that the vertex occurs at 2/3 comma 2/3, right? So 2/3 comma 2/3, that's the vertex. And that vertex has a y-coordinate of 2/3, which basically ends up being our minimum y, because the function opens up from there. And if it opens up from there, then that's the smallest y value we will have.